Alright, so in this video we're going to go over and review 14.1 and 14.2, which is what your quiz is on. So 14.1, 14.2. The main focus of this video is to kind of distinguish between when do we choose a combination, permutation, or just counting, and as well as labeling. So in the last set of notes we went over that, but here are some more problems to kind of figure it out. So number one, how many ways can 3 cars be parked in 10 parking spaces? The key word here is the parked. Since we're parking it, we can think of this 2 ways. We can think of the 3 cars being parked in 10 spaces. Parked again, that tells me that order is going to matter. And why does order matter? Well, think about it if you were coming to homecoming. Would you want to park 3 miles down the block or down the street, or do you want to park right in front of the school? You probably want to park in front of the school. So we got 3 cars, 10 spaces. So n total spaces, and we've got 3 cars. So I've got 10 spaces. I am going to pick 3 cars to park in those. So again, if you need a refresher about how to do that in your calculator, 10, math, we go over probability, and we are picking 3 spaces, 720 ways. Alright, and also same thing, it's 10 factorial over n 10 minus 3 factorial, which will give you your 720. Alright, the next problem has a lot of parts to it. We need 8-letter passwords, and we need to know how many we can have given the following stipulations. So this actually breaks down some rules, and then we got parts to it. The first 3 letters, the first letter can't be a vowel, the second letter cannot be X, Y, or Z. So let's go, we're going to take this goes with A. Find the number of ways to put the first 3 letters. So put some slots here, 1, 2, 3. The first letter cannot be a vowel, so no vowel. Well, how many vowels are there? There's A, E, I, O, U, so 5 vowels. And how many total letters are there? 26 letters in the alphabet, if you don't remember. So no vowel, that's going to be 26, subtract 5. So 21 different things I can put in slot 1. Slot 2 says it cannot be X, Y, or Z, so no X, Y, and Z. So that's excluding 3 letters. So 26 minus 3, that's 23 different options. And finally, the last slot, it says nothing about it. So no restriction. That means it can be any number or any letter, so 26. Multiply those all together, we end up with 1, 2, 5, 5, 8. 558 ways. Alright, next part of the code. It says the 4th and 5th letter. So 4th and 5th letter, that comes down here. Well, 4th and 5th, so let's slot it out. Again, 4th, they can only be vowels. So must be a vowel, must be a vowel. How many vowels? There's 5. 5 times 5, 25 different ways. Alright, moving on to the next part. The last 3 letters. So again, slot it out, 1, 2, 3. Can be any letters except for the sequence AAA. That's one code it cannot be. So we're going to take this and we're going to subtract 1. That's the code AAA. Alright? So any letter, any letter, any letter. So that's 26, 26, 26. Minus 1, which ends up being 17,576 minus the 1 code, which gives us 17,575. Alright, now how many total passwords? We'll take each part and multiply them together. So take part A, multiply it by part B, multiply it by part C. So what is that? That is our 12, 5, 5, 8 multiplied by 25 multiplied by 17, 5, 7, 5. And that gives us a grand total of a lot of passwords. So in the end, we have 5,517,671,250 passwords. So again, a lot of different passwords. Alright, moving on. Next one. Find the number of batting orders. So order, again, keyword here, for 9 players, with the best 2 batters must be second and third. Since they gave us positions, let's go and slot this out. 9 players, best 2 batters must be second and third. So slotting it out, we've got 9 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Second and third position are already chosen for you. There's only one way to do that. Well, how many players are left now? We've got 9 players. We subtract out 2 of the batters. So we're left with, how many players left? 7. So I can put 7 guys here, but now in the next position, I only have 6 guys left. So 6, and I have 5 guys left, 4 guys, 3 guys, 2 guys, 1 guy. Or realize that this goes away and that this is 7 factorial, which ends up being 5,040 orders for batting. Alright, next one. You may choose 5 classmates, choose being a keyword here. 5 classmates out of a group of 15 to accompany you. How many ways? Again, here's that word choose. So what is this telling us? This is telling us we have a combination. So combination, how many do I have? I have 15. So N, 15. How many do I want? I want 5. So R is 5. So writing your combination, 15, choose 5. So again, you can put that in your calculator, or factorials. 15 factorial over 5 factorial, 10 minus 5 factorial. Again, the easier way again is just to put your 10 or your 15, 15, arrow over to probability, choose 5. So 3,003. Different ways you can choose people. Alright, go ahead, flip over. We'll continue. Alright, standard deck of cards. That's 52 cards. How many hands contain 5 cards? Now, do I care about the order that those cards are in? Not really. A hand of cards is going to be a hand of cards no matter what way it comes in. So again, this is a combination. So I've got 52 cards, that's my N. I want 5, so that's R. So 52, choose 5. Again, you can do it as a factorial, or you can just kind of put that in your calculator and get your answer. It's going to be 2, 5, 9, 8, 9, 6, 0. Hands of cards. Or 5 card hands. That makes more sense. Sorry. Alright, an arrangement. Arrangement tells me that order is important. Important. But I've got the word isosceles. That tells me that this is one of those labeling problems, because I have repeating letters. So I need the total number of letters, which is 9, and any repeats. So I've got 1, 2, 3 S's, I've got, let's see, 2 e's. So putting that in, I need my 9 factorial, divide out the repeats, 3 factorial, 2 factorial. Alright, plugging that in your calculator very carefully. 9 factorial, so math, arrow over, and then you're going to divide, put the whole bottom in parentheses, so 9, 3 factorial, oops, arrow over, 2 factorial. And we get 30240, 30,240. Alright, next thing. First, second, and third order. And we've got 10 contestants. That sounds like N. There's 3 positions, so that's R. So we've got a permutation. How do I know that? Again, the order was important here. So I've got 10. I am picking 3. I think we did that one on the front. That's 720 different ways. Alright, next problem. Checking out 3 library books from a list of 8 books. Alright, so library books. Do we care which ones? I mean, yeah, they need to be on the topic, but there can be a lot of different ways that I can do that. So this is going to be another combination. And again, how many do I have? I have 8 total. I'm choosing 3 books. So 8 choose 3. 56 different ways we can choose those books. Moving on. A woman is going out for the evening. She will put on 6 dresses. 1 of 6 dresses. Pair out of 8 pairs of shoes. And go to 1 of 7 different restaurants. So in this case, I've got a bunch of different options going on. So this tells me that I'm going to use counting. So let's put out our slots. Dresses. There's 6. We've got shoes. There's 8 pairs of shoes. In restaurants, we've got 7. Multiply it all together to get our grand total. That's going to be 336 different ways that can be done. Now, number 10 is similar. You're making your own custom pizza. You can choose one of sausage, pepperoni, or bacon. So that's 3 options. Your crust can be thin, thick, garlic, or regular. So that's 4. You can choose to include or not include. So that tells me that there's 2 different ways I can do the following. I've got hot peppers, onions, olives, mushrooms, and sun-dried tomatoes. I can include or not include. So that's 2, 2, 2, 2, and 2. So this becomes a counting problem where I have my meat on my pizza. There's 3 different ways to choose that. I can choose the crust of my pizza, 4 different ways. And then I've got a bunch of different ways to do toppings. 2 times 2 times 2 times 2 times 2. So those are my toppings. Include / not include. So you could condense this to 2 to the 5th power if you wanted to. How many total options does that give me in the end? 384 different ways to make my pizza. So custom pizzas. Finally, there's one more problem here. 30 people in your geometry class. The teacher's going to split them into groups of 3. So 30 people, that's a total. And we're going to be some difficulty. The people with the hardest problems will have 10 students in that group. The medium difficulty is going to be 15. And the easiest questions is going to be a group of 5. Since there's a bunch of different ways to do that, and we're assuming everybody is on equal par in this class, this becomes one of those labeling problems, just like doing isosceles up here. So we've got how many total people? We've got 30 factorial. Oop, I should have done that in black, sorry. 30 people. And I'm going to divide out each individual group. 10, 15, and 5. Now again, when you put this in your calculator, make sure that the bottom goes in parentheses. You get a big number for this one. It's okay to keep it in scientific notation. We'll do 4.658 times 10 to the 11th power. So there's a lot of different ways that a teacher can group the 30 students. And you would think about it, 30 people, grouping them with those different numbers, of course there's going to be a lot of different ways. Alright, so make sure you know how to do these. Make sure you go and review the book work, the notes, and you will be set for tomorrow's quiz.